Hello everyone and welcome back to my channel. So this is going to be the second video now out of the intended order. The project that I've alluded to previously, I think at least twice, is going through somewhat of a development hell. So I'm going to stick this here instead. A little while ago I had a viewer in the comments ask when I was going to do a further update on the gear and centrifugal pumps. I responded to this by explaining that the current diaphragm pump air compressor seems to be the best pump I have, at least for low flow applications. Then, shortly after that, I needed something with more flow and pressure. So, here we are. But before I get into that, just a quick note, there will be more of a sneak peek on the big project at the end of this video for those who want to stick around and check that out. I've come up with a few different versions since the last time I posted anything about the rotary pumps. What I have here in front of you are the parts to the updated gear pump, the updated centrifugal pump, and the larger version of the updated centrifugal pump. However, the biggest improvement in any design I've come up with lately is the thread-on coupling drive. This gives a few advantages, one of them being easily being able to swap either motors or pumps. The other being if there's any misalignment between the pump center and the gearbox or motor center, the coupling should take up any misalignment without any issues. This decreases wear and improves efficiency. On the test version, I'm using a gearbox that I designed to go from a 540 to a 540 pattern. There's a few gear sets available that would fit inside the gearbox case, and the gearbox itself is pretty simple with just a 6mm shaft running on the frame as a bushing. The output of the gearbox in this picture is the 540 adapter plate for the thread-on coupling housing, and an example of it all together. Now I've used this little centrifugal pump for a while, so it's a little bit worn in. So it rattles a little bit, but it still has plenty of life left in it, and will be easily exchangeable when it does die. It's also not recommended to run the pump dry. Everything can heat up and seize up and cause all sorts of problems. So the reason I was looking for the improved pump was a sprayer bar system for my air conditioner. As most of you probably know, it's really hot, and this drastically improves the efficiency of my window unit. Normally there's supposed to be a tray in the bottom that fills up with water and splashes all over the condenser. However, I have drilled a hole in it to drain for another application where I had it, and now this causes a problem. I was originally using the large centrifugal pump, however it didn't make the pressure to run both spray bars that I made so that I could spray down the whole condenser. So I made some improvements to the internal gear pump as well as doubling the flow volume. The only real big issue with this system is, because it's wide open to the air, I get lots and lots of algae in it. Since it's supposed to be nice and cool this week, I switched over to my algae tube, and I'm gonna see if I can farm some algae out of this. The other design improvement I've come up with is a labyrinth seal as opposed to an O-ring type seal. Now this doesn't give a 100% seal, but it does increase the distance that the water has to squeeze through a very small gap, and in practice it seems to seal about as much as the O-ring did, however with much less drag than the O-ring caused. The rest of the assembly goes about the same as any of the other previous pumps of this design, and the original faceplate from the other pumps can be used. If not, it's in with the files listed. However, the housing, the ring gear, and the pinion gear are all new due to the volume and labyrinth seal type. I will be sharing two sets of gears, a tight set and a loose set, depending on the amount of power and pressure you would like to develop. Now for reference, the pump outside on the air conditioner is the loose pump running direct drive, and for the break-in and testing of this pump, I'm going to be using the gearbox mounted motor. Now with the tight gears, that's pretty tight. We'll need a fair amount of power to get it kind of broke in, so I'm using a drill here to get it started. I also ended up gluing the pinion gear on with some super glue. Ultimately the D shaft would be better, but again I'm using the straws still for this, and not a lot of people have access to a machine shop, so it's just easier if I use straight shafts. And here with the trusty fishbowl, I'm going to run it for a little while, make sure everything's broken in, and tighten the face screws on the pump housing as I go, like I did with the previous versions, to run the tighter version of the gears. The loose version of the gears will just run freely at this point, maybe after some break-in with the drill, but after a couple minutes of running shouldn't be a problem at all. Again, do not run these pumps dry, they will seize up. So after about an hour of break-in, I put some fittings on it and I'm running it again, and I should be ready to use for whatever application I need this for. As I've shown before, you can see there's not a lot of leakage out the back of this, which does keep a lot of splashing away from the motor and probably helps with longevity overall. That little bit of leakage there ends up coming in handy as the lubricating fluid and cooling fluid. As well as I put the plug on the end of the straw on the coupling end so that the straw can fill up with water and also work as a coolant. And that's about all I have for improvements on my pumps. I have been working on a completely 3D printed mechanical seal that will hopefully help improve sealing and pressure development. How this will work is there will be an O-ring on the inside of it that will seal it to the shaft. One end of the springy end will be fixed to the shaft, and the other end will push against the back of the pump housing. Now for this application, I was looking for some sort of harder material. I might use the carbon fiber, PETG, or maybe some sort of nylon. In normal application, you would use some sort of ceramic, so I'd like to try to find something that would emulate that, but if the pressure's low, I might be able to get away with certain plastics. It's hard to say, and testing will provide an answer to that, I guess. Now I will be sharing all the files for all the different improved versions of the pump that thread on. For the larger centrifugal pump, I need to make some modifications, and I'm not sure which files I'll be posted, the current versions or the modified version. The current issue with that pump is it leaks through the side of the housing. All of the larger improved pumps run on a 540 motor. I'm using a 12 volt 540 motor that runs at about 8,000 RPM that I picked up at the surplus section at my local Princess Auto, which is kind of like a Canadian Harbor Freight for those who aren't up here in Canada. And that's pretty much it for my pumps. Now on to the next project. I'm not going to comment too much on what's going on here. However, a small explanation of the development hell I mentioned earlier is basically I keep changing my mind of what I want to do with this and how I want to do it. So I got to mull that around, and that keeps slowing everything down. Otherwise, I'm going to be organizing my channels a little bit differently and trying to figure out what the best way to post and manage all of this with my current schedule. With that, I have made 2 other channels, one for my tactical as outdoor equipment and the other one for my robotics. So I will not be posting any more of that stuff on this channel as my main channel, and be more focusing on useful mechanical items and pumps and things. I am currently working on a bigger project for the robotics channel, just to start that off. So overall, everything's kind of up in the air, and summer is dwindling, and I'm trying to get things done before the snow flies. So I apologize for anybody waiting for some specific project I'm working on. I will eventually get back around to it, but I'm just one guy doing this alone, and I have other responsibilities to tend to as well. At any rate, I'm not going to ramble on too long. If you like this, you know what to do, and I hope everyone has a good one. Take it easy.